This is an update on some development I'm doing for a ultra secure web application that I think all apps going forward should adhere to. This is both a recommendation on a spec and a example development which I am undergoing. And what is shown in this diagram and what I'll describe is already extant. Materially extant and operating on the web right now. So it's practicable and it is, as you'll see, very secure. So I call it SALSA, secure. Other words. Anyway, basically, TLS is the common way for web applications to secure communications between an organization and a consumer individual, generally, like going to Facebook or eBay or your bank site. TLS does it when it's out on the web. The problem is there's lots of people who have access on the inside, and web applications are not very secure on the inside. The point of my version of SALSA is to extend the security into data that's kept inside organizations of any type. So it involves encryption, of course, both asymmetric and symmetric, one-way encryption, and heavily relies on password-based encryption. And TLS and other technologies that'll be mentioned rely on certificates, which rely on asymmetric encryption. You have both a public key and a secret key. Obviously, you have to keep the secret key secret, and you will, in order to send data out to an unknown party, consumer, you will encrypt with the secret key, and they will decrypt with the public key, which is readily available. And with the cert, you can send a cert you use to encrypt some data with the secret key, and a consumer of that data will be able to use the verify that the public key belongs to the shipper of that cert, and have various entities on the internet that will vouch for the public key, and thereby ensuring that you are engaging in a conversation with the organization of your choosing. So certs are very important, and they are crucial to TLS, how TLS operates. And TLS is, like I said, is how data that moves across the internet is secured. A recent advancement is that Acme is an automated version of updating certificates. You can run some code to interact with one of those certifiers, vouchers on the internet, and get a new certificate for a new secret key that you've established. Another thing is load balancing. Load balancing, of course, is you're going to have multiple versions of this operator here on different servers, so you will need to distribute the access amongst those. And an important concept with load balancing, or also leveraging multiple servers and hosting multiple applications, is SNI, and that's where the server name is inside of early TLS data, and it can be pulled out before TLS becomes completely encrypted, and you therefore know which servers to send your TLS data to, your internet access. So you could have, just to be simple about it, you could host both a Google site and say a Facebook or an eBay site on the same group of servers, and a load balancer can pick out the name, either Google or Facebook or eBay, and pick which server to send it to, even though it is encrypted traffic. So that's server name indicator. And also important technology are whether you use a SQL database or a non-SQL database. And SQL is very good. Structured query language is a very good way of organized data, but for quick and dirty, NoSQL is can be very good, and that's good for kind of cache data, but that still has some searchability. So some advancements I've made since the last time I made such an update are I have basically an API proxy, what it's called, but it's also a load balancer, and it will parse the TLS data that comes in just to get the server name indicator, so as to know which server to send it to. So I can have multiple sites with this reference code that I'm developing, and I'll have a sticky load balancer that will also pick out a server, stick with the same server based upon some information in the internet, such as the internet address. Basically, any internet address data that has established a connection here will want to go back to the same server, because a connection is going to be cached here. And it's not very common to cache, or it has in the past not been preferable to cache connections, and that's why they call it RESTful. But I believe it'll become necessary to at least do some caching of connections for very good security. So load balancing will have to be sticky, so as to direct traffic from a certain internet address to a certain server, so that connection can be maintained and secured by maintaining that connection. So those are the new things: TLS parsing with server name indication and sticky load balancing. And of course, there's a control access to this API proxy, which has been around for a while, and improvements to a NoSQL database that I call Mongrel, and basically uses JSON to store and to move data, and that is parsed properly and stored and is searchable very easily, and data brought out of it. So once this load balancing and SNI is done, connection, the data is forwarded on to the server already picked, or if a new connection is required, a server of some picking. And once it gets that server, the account will be cached. It'll be, and the data will be checked for, the data that comes in will be checked for security information to ensure that it is not some kind of replay from a hacker who has information from past history. So one reason why it has to be cached. So it's a sequence of steps that have to be followed, and to replay those, it'll send off a red flag, and the accesses to the information will automatically be shut down. So so the site can be maintained with some user interface code, which I've been implemented with Java. It's JSF-like, though I refuse to use config files that are not Java. So it's Java that is mapped to HTML constructs, and that's like JSF, only it's done purely in Java and no HTML. And then there's a server layer where various activities relating to a site are done, and then also in this unit, TLS is terminating, so there will be a certificate with the corresponding secret encryption key. So the automated certificate process will be launched from this area also, and that has been proven, improved and proven a few times over the last few months. And it also uses the NoSQL database called Mongrel. But this is to be automated when it is determined that the certificate that this chunk of code is using has expired or will about to be expired. But one important aspect of all this is that the secret key has to be kept secret along with some operational data. So in order to run this application, that data will have to be decrypted, and that data has been encrypted with a password. So it is password-based encrypted data, so that no voyeurs can look into this application or start it and run it without having the password that permits them so to do. So that'll be kept in another table of operational data that is password-based encrypted and requires an operator of this application to log in. But as for the consumers of the data, that is also organized into some password-based zones with some designs to make it extremely difficult for anyone to do any kind of voyeurism spying. Generally, a login to a system, an organization, will entail what's called a principal. And so that's where you have a username and a password, and then they get in and they have a bunch of organization data, maybe business data or other, and then they have some identity information. So ordinarily you kind of mix some of this together, or don't separate it well enough in terms of the connections that can be made just by being able to access these databases. So I've devised a way to segment that data so that anyone with access to each one of those cannot automatically put certain data together so as to compromise the security of any consumer of this web application. So that is that you'll use identity keys basically to associate called business data or identity data, and they will each be different, but they will also be password-based encrypted. So even if you had access to the table for logins, you would only see encrypted data, and you would not be able to make any connection to any identities, and you would not be able to make any connection to any business data. You really have to have the decryption key to decrypt the identity locator, basically, of the business data, and it's also a different one for the identity data. So, and that has been functional for quite some time. That I've been operating a site that I am operating for this, but most recently, in fact, over the last few days, I've been running Acme again, and improving its performance. It was mostly automated, but with some minor stopping points that had to be ameliorated and so that it could flow from beginning to end without intervention from the operator. So again, an interaction with this web application would be a consumer of the web application submitting username and password. It'll be very securely handled by TLS in here. When it gets in here, they'll use the operator's code to look and compare basically the username to a principal, and then they'll use the submitted password to make sure that to decrypt the principal's information. And once that's successful, you will then have these keys to look up data, basically. So the only way to get at a data is to even know what data to look at is by a successful password entry by the user. The consumer of the application. So that's the crux, and that's how data moving within the application has complete secured to even the people who run the application. You may give database access to operators here, but this information is all encrypted and has been encrypted using the password of the consumer. So not only will they not be able to associate some principal or some identity with the data, they won't be able to see the data anyway because it's encrypted. So it's several layers of encryption and obfuscation so that no voyeurs either working at the organization or who manage to compromise the organization, such as malware, will be able to make heads or tails of the data that's on that system. So that's the gist of it so far.